Hello, Assalamu alaikum. Today we will see lecture number 15 from the subject numerical methods, and today's topic is how to choose an interpolation method. In the last lecture we saw what is an interpolation and what are the different methods of interpolation which we have. Now the question is, if we have lots of interpolation methods for estimating any value which is not known to us, then how can we choose any one amongst them, and which one is better at which place, like that. Okay, so today we will see that. Okay, fine. See, okay, as I told you that let me write it. We have various methods for interpolation. Number one, if we are having equally spaced data points, then we use forward difference interpolation, or we use Newton's forward difference interpolation, or Newton's backward difference interpolation method at that time. Say for example, you know that we have an independent variable and we have a dependent variable. Say if my data points, the values of x are called as data points, these are called as the argument values as well, 1 2 3 4 5 and so on, like the values are 10 20 30 40 and 50. If these data points are equally spaced means the difference between them are equal. If you will see, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. So yes, they are equally spaced. So at that point of time, we can either go with the forward difference interpolation method, or we can either go with the Newton's backward difference interpolation. Now, when to use Newton's forward difference interpolation and when to use Newton's backward difference interpolation? The thing is, I would write it over here. If the function values, whichever value we will get or we have to find, lies at the upper half of data set or data points, then we use Newton's forward difference interpolation. Okay, what do you mean by that? Say for example, I am having n number of data points. In this case, I have only 5 data points. Now, if I have to estimate the value, say for example at 1.5 or maybe at 2.5, like that, 2.8, 2.9, and that comes in the upper half of the set. इस डेटा पॉइंट के अगर मेरे पास n नंबर ऑफ एलिमेंट्स हैं और पहले कुछ ही डेटा पॉइंट्स के बीच में से मुझे वैल्यू को एस्टिमेट करना है, आई हैव टू फाइंड द वैल्यू ऑफ y इन व्हेन द वैल्यू ऑफ x lies in the upper half of the table or upper half of the data set. At that point of time, what I use is Newton's forward difference interpolation method. Or if the function values lies at the lower half of the table, lower half of the table or data set, whatever you can Then we use Newton's backward difference interpolation. Okay, that means अगर मेरे पास जो ये डेटा सेट्स हैं, से आई एम हैविंग 10, 20, 100 डेटा पॉइंट्स, लेकिन जो वैल्यू मुझे एस्टिमेट करना है वो इन डेटा पॉइंट्स के लास्ट के एलिमेंट्स में आ जाता है. से फॉर एग्जांपल मुझे एस्टिमेट करना है यहाँ पे 4.9, या मुझे एस्टिमेट करना है 3.5. तो इट कम्स अकॉर्डिंग टू दिस लिस्ट. मुझे जो एस्टिमेट वैल्यू करना है वो इन डेटा पॉइंट्स के नीचे वाले डेटा एलिमेंट्स के बीच में एस्टिमेट करना है. तो उस टाइम पे मैं क्या यूज़ करती हूँ, उस टाइम पे जो मुझे मेथड यूज़ करना है इंटरपोलेशन का, दैट वुड बी न्यूटन्स बैकवर्ड डिफरेंस इंटरपोलेशन. ओके, till now we saw only two things, that if our data set is equally spaced and the value of y which I have to estimate with respect to the value of x that lies in the upper half of the data set, the method of interpolation which I have to use is the Newton's forward difference interpolation. And if the value of y which I have to estimate lies in the lower half of the data set, then the method of interpolation which we have to use would be Newton's backward difference interpolation. Okay, now this is when our data set are equally spaced. Now if the function values are unequally spaced, then we use Lagrangian's interpolation or Newton's divided difference formula, or you can say Newton's divided difference interpolation or method. जिस तरीके से भी आप बोलेंगे doesn't matter, or method. So for example, these are our data points. Say I am having 1, 9, 8, 20 and any value, say 20, 50, 30, 40, anything, any function value. In this case, our data points are not equally spaced, they are unequally spaced. So at that point of time, the method of interpolation which we use is the Lagrangian's interpolation or Newton's divided difference interpolation method. Now in our syllabus, we don't have to do Newton's divided difference interpolation, but we have to perform Lagrangian's interpolation method. But it's not necessary always. If in your examination you would be given equally spaced data points, okay, and you would be asked to solve them using the Lagrangian's interpolation, you can solve that. There is no issue in that. But for the most important thing, for unequally spaced data points, it is said that you cannot use Newton's divided or backward difference interpolation. You either have to do this one or this one. Okay, so this was about the unequally spaced data points. Now if the function values are at the middle of the equally spaced data sets, then we apply Stirling's formula and Basel's formula. Okay. Now this is again very important. Now what if you are having equally spaced data sets like 1, 2, 3, 4, 5, 6, 9, 10 like this, and any values of y, and you have to estimate the value which lies in the middle of the data set. like over here. You know, if we are having equally spaced data sets and our value lies in the upper half of the table, then we have to use Newton's forward difference interpolation method. And if the value which we have to estimate lies in the lower half of the table, then we have to go with the Newton's backward difference interpolation method. But if we have to find the value in equally spaced data points and the value of estimation lies in the middle or at the middle, then we have to either use Stirling's formula or we have to use the Basel's formula. So these are the methods which we have to use and which we have to choose according to our data sets. We have to find out whether our data sets are equally spaced or they are unequally spaced, and then we have to go with that and solve the problems. That means we have to go and estimate the values of y which are not known to us with the help of the independent variable. So today we will only study this much. Thank you.